something. Okay, so what's the first thing we do? Separate. Okay, so we're going to separate. So I'll do it in a couple steps. You could do it all in one. Had we already done this one together? No? Okay, we did other ones. All right. I'm just making sure before I did it again. X squared times y minus 1 times dx. Then that's going to give me 1 over y minus 1 dy equals x squared dx. Okay? Do we all get that far so good? Okay. That right there, that separation of variables, that's 1 point. Yay! Okay. Then we need to integrate both sides, right? So I'm going to integrate. When you integrate the left-hand side, what are we going to get? Natural log of the absolute value of y minus 1. Now, technically, this is a u substitution because this is a function inside of a function. But because there's not a number in front of y, you can kind of just know that that's where you go to. But you got to be careful. Like if I had 1 over 3y minus 7, then I wouldn't just end up with this. I'd have to do my u substitution and stuff. We okay with that? All right. And then that equals, what would this be? X cubed over 3, and then what? Plus c. Okay, so the scoring on this part, now my understanding is these used to be 6 points, they're now 5 points, and I believe the point that they combined, I'm just double checking myself, yeah. Okay, so you get a point for the separation, which we did. You get a point for both antiderivatives, and you get a point for the constant of integration. Well, you had to take an antiderivative of both sides. You had to integrate both sides. So this used to be 2 points, one for the left and one for the right, but I think they have combined that into being 1 point. Okay. That point is for the plus c. Mm-hmm. Yeah. Mm-hmm. So there's 3 of your 5 points right there. Have we even done any of the hard stuff yet? No. Or the stuff where you've gotten stuck? No. Okay, so here's where we can kind of, I don't want to teach to the test type of thing, but like the harder parts of this is the algebra that comes in sometimes when we are trying to solve for y and whatnot. We can solve for y right now, or we could put in our initial condition and then solve for y like I had shown you originally. And it doesn't really matter either way. Sometimes it is easier to solve for y first, and sometimes it's easier to put in the initial condition first. But I can tell you this. Your next 2 points come from using the initial condition and finding c, and then actually solving for y. So if you're going to get stuck in something, like if you try to solve for y and you're like, I don't know what the heck's going on here, and you solve, I guess if you solve for y incorrectly and you still use your initial condition, then you're going to be okay. But we could use the initial condition, stop, and we'd have 4 of our 5 points. Does that make sense to you? Like we'd be done then. Well, I mean, not done, but we'd have something there. So let's go ahead on this one, and let's just use our initial condition, find c, and then we can go from there. And then I'm going to show you also what it would look like if we didn't find c first. We'll kind of do it both ways. I think it's good. So f of 0 equals 3. Is this where y'all substituted it in? Yes? Okay, so I'm going to have the natural log, the absolute value of 3 minus 1 equals 0 cubed over 3 plus c. So that means that the natural log of the absolute value of 2 equals c, which is really just the natural log of 2. I don't think so. I think they want, because like, where did this come from? You got to show that you used the initial condition. And so that's why I say all the time that your first step, 0 work, substituting it in is important so that they see where that comes from. Going from here to here, do I have to write 20 steps, even if it's necessary? No. But you do need to show that you substituted that in. Does that make sense? That's a good question. Okay, so now I have found C. I used my initial condition. That's another point. All right? And that I'm just going to use, moving forward, I'm just going to use the natural log of 2 because the absolute value of 2 is just 2, right? So then when I substitute this in, back in over here, I'm going to get the natural log of the absolute value of y minus 1 equals x cubed over 3 plus, not plus c, because we just found that, natural log of 2. I do that almost every time and have to erase it almost every single time. All right, so now what I want to do is I want to solve for y, okay? The opposite, or what's the inverse of a log? What's the inverse of a natural log? I'm sorry. No. Okay, that's not the inverse. That's the antiderivative or the derivative, depending on where you're going with that, okay? But I'm just talking straight up inverses. What are our logs always connected to? When we graph, when I say this is what a log looks like, exponential, right? So E, so natural log goes with E. That's how you undo a log, okay? Does that make sense to you? So I'm going to take both of these, and I'm going to take E to this power. Basically, E becomes the base, those become the powers by me putting little e's there, okay? Just like the natural log of E is 1, E to the natural log, if I did this, these kind of, because these are inverses of each other, on this left-hand side, I am just left with y minus 1. Now over here, I don't get to just get my exponent here. What I have, and I think we talked about this the other day, if I have e to the x plus 2, how can I rewrite that? Oops, yes, e to the x times e to the 2, right? Okay, and I'm just making up those numbers because it doesn't really have anything to do with this, but I'm just making sure that we understand how that works. That means here, this is going to be e to the x cubed over 3 times e to the natural log of 2. Because this still has the variable in it, right? Well, just like here, jeez, sensitive today. Just like here, e to the natural log, this just became y minus 1. This right here, I don't have a natural log in there anymore, but I do have one here. So this part right here, this is just going to become 2. So I get y minus 1 equals e, well, let me put the 2 in the front. 2 times e to the x cubed over 3. No, this is multiplication. Right, this becomes the exponent of e. So then that means that y equals 2 times e to the x cubed over 3 plus 1. So after all of that, simple point, simple point, simple point, simple point, yuck, right? But there's that point. And then this is what it says. You can get a maximum of 3 out of 6, which is now 2 out of 5, if no constant of integration. So even if you do everything right, but you don't put your C in this step right here, you're not getting any of the rest of that credit. And you're not getting any of it if you don't actually show your separation of variables and you skip too many steps. Okay? Does that make sense to you? Now I want to do this same question starting from here. Now on the back of the page that you're on, it's blank, right? Yeah. So if you wanted, you could just fold it up so you can still see this work. And then I'm going to have to rewrite this on the next page. Natural log of y minus 1. Okay. Absolute value of y minus 1. Because there's so many different ways to do things, and different people have different opinions about what is the, quote, best way to do things. And what I was going to say at the beginning before I started talking about how you can get your points was that before we use our initial condition, sometimes it is easier when you have logs at this step after you integrate to go ahead and solve for y first. If you don't have logs, I would just go ahead and substitute it in so we don't mess anything up. But I'm just going to show you how to do this too, and if you feel like this looks less confusing to you, maybe this is the way you want to go. Like I said, it's kind of up to you. But instead of finding c first, we're still going to go about it the same way, meaning that we make e the base and both sides become our exponents, right? So when I take e to the natural log of the absolute value of y minus 1, that gives me y minus 1. We are just dropping the absolute values. They get very confusing as to why. You're just going to have to go with it. Is somebody knocking or am I crazy? Oh. I was like, is somebody knocking? Okay, thank you. So over here, even though that what I have in orange is being added, they are exponents now, yes? So this becomes e to the x cubed over 3 times e to the c power. I know, he doesn't care. She called you out. All right, so do you understand where this came from? Okay, now e to the c, it's just some constant, right? So that means that I can just make that, whatever this is, since this is a constant, this becomes y minus 1 equals c times e to the x cubed over 3. And then I can solve for y equals c times e to the x cubed over 3 plus 1. Now that I have solved for y, then we can use our initial condition to actually figure out what c is and finish this off. And that means, what was my y? Was it 3? Y is 0 or y is 3? Y is 3. Y is 3. That's equal to c times e to the 0 over 3 power plus 1. What is e to the 0 over 3 power? 0. So that makes this what? 1. Anything to the 0 power is 1. If it's zeroed out, that'd be a problem because c would be gone, right? So this is just 1. So that means that when I subtract, then I got c equals 2, which we already found on the other one, right? So that means that y equals 2 times e to the x cubed over 3 power plus 1. Here's what I can tell you about this. And here's what I'm not 100% sure about. And then I need to find out. I need to ask. Miss Bruce would probably know. By the way that things are graded, if we had found y, and let's just say we messed this up. Like, let's say that this was wrong. We tried, and that was a hot mess. But if I still use my initial condition and find c, I think I should still get that point. You with me on that? So it doesn't really matter if I find y first or second, if it's going to be a hot mess and I might get lost in it. And you know what? If you get lost in it, you get 4 out of the 5 points. That's still huge on a free response question. You with me on that? So don't look at it and be so afraid that it's going to get nasty and you might get lost in the algebra. And even if it's making sense, if you make some little ridiculous mistake, the other stuff, as long as you're careful with it, you can still get a lot of points out of it. Okay? We good on that? All right. Yes. The beginning of April. April 8th, 10th. I don't think we'll be 100% finished with the curriculum yet, but we should be pretty close. And then we'll just grade it based on that. Okay. We'll talk a little bit more about it before it comes up. All right, let's go back to this one. Now, this next one, we don't have a log in it. Do we try this one? Why not? Ugh, stuck on the first one. Okay, I see some of us tried. Good job if we actually tried. Let's see how many points we got on our own. Okay, so we're going to consider this differential equation. What's step 1? Separate. So that means dy would be equal to y squared times 6 minus 2x times dx. When I divide this over here, I'm going to get 1 over y squared, but that's y to the negative 2. I'm just going to go ahead and write that. If you have 1 over y squared, totally fine. 6 minus 2x dx. Okay, so we separated. That's 1 point. Okay? Then let's integrate. I'll give you a second for those of you that didn't get this far. Those of you that did, just double check that you agree with your own integration. That is an excellent question. And just as I wrote that, I'm wondering that myself. Did y'all understand her question? I'm thinking yes, because I know that I have seen Miss Bruce write it that way, and she wouldn't write it that way if that was not okay, but I am going to ask about that as well. That is a very good question. I'm thinking yes, but I will find out for sure, because otherwise I do not want to be doing this wrong. All right, so this would be okay, I think that's what I got. And if you have in here, if you have another step where like this isn't simplified because you have this over -1 and you have 2 over 2 there, that's totally fine at this point. Okay? But we've integrated both sides. That is another point. Okay? Everybody okay with that? All right, good deal. And so then, oh, and I have my plus C, so that's another point. There's 3 of your 5 points that you could get right there. There's 3 of them right there. So I would say, since I don't have a log anywhere, that I'm going to substitute my initial condition. So this would give me negative. Now this would be 1/4 to the -1 power. If you're going to do that correctly, that's great. You may want to rewrite this as -1 over y equals 6x minus x squared plus c, so that you do that correctly. Okay? But negative, I can also write it like that. That's fine. That's equal to, then my x is 3. This is 6 times 3 minus 3 squared plus c. Okay? And I used my initial condition. I substituted it in, and that should give me something. And I just hope that I do the rest of it right. So this is going to give me -4 equals 18 minus 9 plus c. And then, so that's going to give me 9. I said -13. Okay. -13 equals c. Everybody good with all that? Okay. Then they definitely will. Then I'm going to get -1 over y equals 6x minus x squared minus 13. Now, this is not in your, standard form for quadratics. Nobody cares, okay? And then here, if I want to, really when I end up with this, you can kind of think of it as, these two things really just switch places. But if I multiply both sides by this 6x minus x squared, multiply and divide by y, do all that kind of stuff, I'm going to end up with -1 over 6x minus x squared minus 13 equals y. Okay? Everybody okay with that? Yes. That's fine. So like you have y equals 1 over -6 plus x squared plus 13. Yep, totally fine. Remember, if you have a rational like this, if yours doesn't match this exactly, if you change every single sign on every single term and it's the same, then you're good. Okay. As long, okay, when you pull a negative out in front, I can't just pull it out in front here, take this negative and put it here. That would be wrong. This one could just be out in front instead. Okay, you just got to make sure you're still really saying what you're trying to say with it. Okay, what questions you got? Did we get most of our points if we actually did it? Yes? Huh? Sure, I will stop what I'm doing so I can write you a pass. Front back, wait, what are we skipping? Did it? I probably copied it wrong. Oh, that means that I probably put them in the wrong order. Because I think they're all in here. It's just, I just don't have them in the right order. So we can actually go, well, I don't know. Let's find this one. I think what happened is I copied them on single-sided, and when I put them in the copy machine, I didn't put them in the right order. So let's just find this one. Because that's the order I think I have the scoring in here. I'll really get me confused. Okay. Yeah. All right, here we go. So I'm guessing we maybe didn't get this far. Well, let's go back and look at the ones that you actually got to then. Will that be better? What? Show me where so I can get to the right thing. It says practice set 2 at the top. Well, what is this? Oh, that says part 2. Ah, that's where I went wrong. Here we go. Find this one, which is probably your next thing. Are we here? Everybody find this one? Sorry, I changed my mind and decided to go with something I had already done so we can look at them. All right. So the first thing I want to do is separate, which is going to give me e to the 2y. What? You did do this one? Oh, we separated and that was it?
Yes, that's all we did.
Yes? Okay. Well, if we did the whole thing, we'll do it again. Apparently nobody else remembers that we did it together. Equals 3x squared dx. Or is this the one that I know, but I was thinking, is it? It's not this other one. Like I did some random one. I did do it. I did do the whole thing. We got this far. You're right. It was the one I made you write down because I didn't think it was in here. Got it. So, but then we didn't finish, right? Okay, so this is the one in your notes that we did have half done. We got here. Okay? You're right, it is the exact same question. No wonder I thought it was a good question. I was like, I want to make sure you have one of these. So we had the e's in there. Can we start here then? Okay, let's look at our points. We got 1 point for the separation, 1 point for the integration, 1 point for this. So I got you to the 3 points, right? So then we use our initial condition, 1/2 times e to the 2 times 1/2 equals 0 cubed plus c. All right, so this is e to the first power, so this is 1/2 e equals c. There's our c. Then we're going to go put this in here, substitute it back in here, and I'm going to get 1/2 times e to the 2y power equals x cubed plus 1/2 e. Everybody good? Okay, so before we can do anything else with this, we need to, before I can do anything about getting the y out of here, I'm going to multiply through everything by 2. So I'm going to get e to the 2y equals 2x cubed plus e. Now what can I do to get the 2y out of the exponent? Natural log. Very good. I can take the natural log of both sides. So when I take the natural log of this, natural log over here, then what happens to this 2y? It comes out front, right? And natural log of e is just 1. So I'm going to get 2y equals the natural log of 2x cubed plus e. I can't do anything with this. I know that the natural log of e is 1, but I cannot make this into a 1 at this point, okay? Because I can't split the addition there. We're good with that? Doesn't work the same way as it did with exponents, but that's fine. Even if I could simplify it, I don't need to. All I need to do is get y by itself. So then y is equal to the natural log of 2x cubed plus e all over 2. Or I could put a 1/2 out in front. Either way, it's the same thing. Okay. We okay on that one? Yes? Do what? What happened to, I multiply both sides by 2. Okay. We okay on that one? All right, so what was the next one that you had gone to then? Oh yeah, I thought it wasn't on here, and that's why I wrote it out. Let's see. So we did that. It's this one. Okay. So let me find this since I've got this all discombobulated now. This was in the well, I don't even know where it is for this. I think we can figure out the scoring without me doing that then. Okay, so I'm going to, this is going to give me 1 over y minus 1 times dy equals 1 over x squared dx. Do we agree with that? Yes? That is separated. That's a point. Then we are going to integrate both sides, right? And when I do that, what do I get on the left when I integrate it? Natural log of what? Absolute value of y minus 1 equals, well, this is really x squared, so that's really x to the negative 2 power, yes? So then that's going to give me what? Yeah, over negative, yeah, I can put the negative x over, yeah, absolutely. And then plus c. Yeah, I could totally just make that a negative x. Everybody okay with that? All right, now, I've got a log in this. I'm thinking I might want to go ahead and, now I've separated, I've integrated, I have my constant of integration. That is 3 points right there. 3 points. 3 of my 5. Have we done anything crazy hard yet? No. So don't get to 1 and just start overthinking and getting your own mind. Now, at this point, before I move forward for myself, I think I want to rewrite this as negative 1 over x plus c. Isn't that what that is? I think that would be helpful to me myself. Now, because it has a log in it, this is the one where I think sometimes it's going to be better for you to go ahead and solve for y first. So I'm going to take both of them. E becomes the base. What's on either side of my equal sign becomes my exponent. So then e to the natural log of y minus 1 becomes y minus 1 equals, and then this is e to the negative 1 over x plus c power. So then I can rewrite this as y minus 1 equals e to the negative 1 over x times what? E to the c. And then e to the c is just c. So this is going to give me y equals c times e to the negative 1 over x plus 1. I just moved the 1 as I did it. Yeah, we have to isolate y. We still need to use our initial condition, which we could have done first, but I think with the logs. And the other reason is when you do this and we're just dropping these absolute values, you're going to get, you're more likely to get the correct equation in the end without having to overthink it. So it's better to just solve for y. Then when we substitute in our initial condition, this is 0 equals c times e to the negative 1/2, right? Plus 1. We agree with all that? Okay, trying to solve for c, yes? So I'm going to subtract 1. That's equal to c times e to the negative 1/2 So negative 1 over e to the negative 1/2 equals c. Now, could I fix that over there on the left? I could. Do I have to? No, I do not. So I would leave it like that so you don't mess up on a sign or an exponent. You with me on that? It's just safer, just leave it. So then this gives me y equals negative 1 over e to the negative 1/2 times e to the negative 1 over x plus 1. And you're done. Okay? Leave it yucky. Doesn't matter. You solved for y, you found c, it doesn't look beautiful, you're fine. And if I could actually find where I worked this one, because now that I'm all got this all messed up, can't even find that one. I don't know what happened to it. But that probably doesn't match the answer key exactly, but it's totally fine just like it is. Okay? We good? All right. Let's talk about the baby bird. We can at least get the baby bird started. Are all y'all at the baby bird problem here? Okay, so this is a more recent one. The rate at which a baby bird gains weight is proportional to the difference between the adult weight and its current weight. Its time t equals 0. When the bird is first weighed, its weight is 20 grams. If b of t is the weight of the bird in grams at time t days after it's first weighed, then, here's the derivative, let y equal b of t be the solution to the differential equation with this initial condition. Okay. Is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? And explain your reasoning. How the heck are we even going to figure that out? That's a lot of words. Leave it to a scientist. Just don't worry about it. Let them figure it out. What are bird experts called? Ornithologists? Is that what a bird person is? I think that sounds right. I'm probably making up words. I don't know. I know that's a word. I'm pretty sure that's like a bird expert is an ornithologist. If not, I don't know what that person is then. All right. So what in the equation that they gave us, what is the weight? What variable represents the weight? B, okay, or Y, yeah. B, because T is the time, and it says B of T is the weight, right? We found, or they gave us, we didn't find anything, they gave us the derivative. What does the derivative of anything represent for you? The slope, which a fancy way to say slope is rate of change. So the faster, we're talking about the rate, yes? So can you find the rate at which it's gaining weight when it's 40 grams? Yes. So if I do dB dt evaluated at B equals what? 40? If I do that, that's going to give me 1/5 times 100 minus 40. So that's 60 over 5. And what is that? No. I know it's not that. 12. And it's 12 what? Grams per day. Okay? All right, so then we're going to do the same thing. dB dt evaluated at B equals what? 70. So that's going to give me 1/5 times 100 minus 70, which gives me 30 over 5, which is 6 grams per day. Okay. Let me find the scoring on this one, because that's not one that I just know off the top of my head for scoring-wise. Here's our baby bird. All right, so when you get 1 point for knowing to use dB dt. 1 point. Now, I want you to think about that. That question had a ton of words in it, right? Y'all read A, and I was like, what do we do? And there were crickets in this room. But did you hear the questions I asked you? Like, what is the grams? It's the, what does this mean? This is the rate. Like, they gave it to me. We use calculus knowledge to know to use this, but all we did was some arithmetic, right? And then when we can say, you can say this, you can do it in words, or you can put it in symbols, like whatever makes the most sense to you. But, or you can write out when the baby bird is 40 grams, it is measuring blah, blah, blah. I mean, we have all our work there. But if we say that dB dt evaluated at b equals 40, is that greater than or less than the other one? Greater than. So I can say that's greater than dB dt evaluated at b equals 70. Therefore, what was the question? Is it gaining weight faster when it weighs 40 grams or when it weighs 70? So what is it? What? It's the bird is gaining weight faster when it weighs 40 because 40 is greater than 70. The bird is gaining weight faster. Gaining weight faster when it weighs 40 grams. Okay. And then that's a point right there. So A was 2 points. How many points is it? How many total points is a free response question? Do you remember? We haven't talked about it a lot, but it's 9. So this is 2 of our 9 points. Even if you didn't get this written out, you should be able to get a point here to know we're talking about rate and you're supposed to substitute some stuff in. Does that make sense? We good on that? All right. Let's see if we can get through the B part. So the B part says, find, what the heck does that mean? Do you know what that means? The second derivative, right? So I'm going to rewrite the first derivative right here just so I can see it since I've scrolled and I can't see what I have up there. So dB dt is equal to 1/5 times 100 minus b. Might not be a bad idea for you to even like rewrite it when you're doing your work so that you can, follow what you're doing here. So now the other thing is very important that you get these 2's in the right place when you do the second derivative. Otherwise, they don't like to give you credit for that. So make sure you're paying attention to where they go. I mean, it's in the question, so we didn't have to really worry too much about that. So when I take this second derivative, I'm going to get this 1/5 out here, right, times the derivative of negative, this is going to be 0, right? This is negative b, so that would be a -1. But is it just plain old -1? It's -1 dB dt. Okay, remember when we found the derivatives like that? Now, I'm not 100% finished. It says find this in terms of b. This is not in terms of b. This is right now is in terms of dB dt. So we have this. This is dB dt. I need to substitute it back in there. So d2b dt2 equals 1/5. Oh, that's a 15. Hang on. Don't do that. I'm actually going to make that a -1/5. I don't know why the color's changed. And then I'm going to substitute in that 1/5 times 100 minus b. I'm going to leave it like that because I don't want to simplify anything and mess anything up. All I did was take this -1 and make that negative, and then I substituted this in right there where that went. That's where that came from. Okay? Now it's in terms of B, because all I have over there is B. That's going to get me 1 point. Okay? Then it says, use this to explain why the graph of B cannot resemble the following graph. Okay, so look at this graph here. Concave what? Up and then concave down. Yes? So it's concave up for a while, and then it is concave down. This is the second derivative. So when you look at your fun charts, okay, is the second derivative is negative sometimes, right? Because if baby bird, if I substituted in that 40 like I did up here, this is positive times negative. That gives me a negative second derivative, which means it would be concave down the whole, and clearly this is concave up at some point. So we're concave up at some point and concave down, and that's not what's actually happening here. Okay? Because if we start with 0, from 0 to 100, our weight from 0 to 100, it's going to have to be, negative the whole time. Can't be concave up. So let's put that in words somehow. I would say d2b over dt squared is is less than 0 from 0 to 100. Do you agree with that? Because if I put anything less than 100 in there, my answer is going to be negative, right? Okay? And therefore, concave down. All right? We good with that? And this graph is concave up at some point, which I guess we still have to say. Yeah. We all okay on that? Yes? So here's a point, here's a point. Here's the deal. Even if you feel like you couldn't do that, could you do that? Right? Because this is not an easy question. They're not all going to be easy. Are you going to be confident to get all 9 points every single time? You're not, and that's okay. If that happens and you're like, I don't even know what the heck I was supposed to do there, don't give up on C, all right? Because you will be able to do C. And I will go through and I'm going to do the rest of these that we haven't done. I'm going to talk through them, and I want you to go through that video tomorrow so that we can move on Thursday. We good? Where are you going tomorrow? 5:43. 5:43.